Hi, welcome to product review by watthour. In this video we are going to test this module at all different voltages of 12 volts, 19.2 volts, 24 and 36 volts input, and all standard output voltages will be tested with different current. We are going to have a look at the components under the magnifier. I'm going to show you the thermal image to see which part is getting hot when it is used with the ripples under different current and voltage conditions, and at the end I will present my conclusion. Let's get started with this. I purchased this from AliExpress for $25.28 with $2.82 shipping. You can purchase it. I will provide you the link. Make sure to purchase it from the link below. I will receive some commission. It will help me. Here are the specifications for this module. Input voltage is 11 to 27 volts, and output voltage is up to 50 volts from whatever your input voltage is. It says output power 500 watts. We are going to test it, and these are the current that it consumes. For example, input is 12 volts, output 36 volts. It will consume 67 milliampere, and for this voltage it will be 80. And for 36 volts, when the voltage is higher, the input current, as you can see, the output current increases with output voltage increases. Efficiency is 92 to 95%, which I'm going to test it. And the temperature, the fan will start running when if the temperature goes, the fan will start running when the temperature reaches 36 degrees Celsius. So if you just want whatever is at the input to get it at the output, just make this short circuit. Otherwise, just leave it. This pen and these two terminals are 12 volts, half ampere. And when you rotate this clockwise, you set the output voltage, which is shown here. Let's open the box. They ship it like this. Here, I just opened it for the first time. That's it. No paper, no document or anything. Actually, the model is ZK PW500, so ZK is also here. And here, this has been labeled as an output. It says maximum 50 volts. This is a power out, and this is a power in. So this is input, VN and ground. It has been labeled. So this is positive, that's negative. And here, this is out and out plus, out minus. And here, DC 12 volts out. For some reason, if you need 12 volts, that's the output. These are the fuses that we have. Two 40 ampere fuse. So this is 80 ampere. I'm connecting ground to the left side and positive to the right side. Okay. Around 40 milliampere is being drained. Right now, 24 volts. So here, input is 14.9 volts, and output shows 24 volts. (26) 30 volts now. 34. That's nice because I'm rotating it clockwise, and also there is a symbol that says clockwise will increase. (41 volts). Let's see. 48. So 50 volts, we should not go above that. Visually, it works fine. We're going to test it. Now let's have a look at the components under the magnifier. First, we will look at this chip here beside the display. This is HK32F030. The datasheet for HK32F030. This is a microcontroller unit, 72 megahertz. I'll provide you the datasheet. Now let's have a look at this chip that we can see in here. So this is XL1509 converter with this inductor beside it. There is a datasheet for XL1509. This is a step-down converter or back converter with output of 40 volts. Maximum current is 2 ampere. And let's have a look at these two shunt resistors here. This is a 0.1 10 milliohm resistor. Two of them, they are connected in parallel. So the amount of the value will be divided by 2. So it's 5 milliohm resistor. Value for this voltage regulator variable resistor, people also call potentiometer. So this number is 50350 and then 30, 50 kilo ohm. These large pieces of semiconductors, 2 here and 2 here. 2 must be diode and 2 must be MOSFETs, but let's see. So this is the RU6888. And the other one, let's rotate this on the other side and let's see if we can read it. So this is a diode, MBR, and as you can see, MBRF 30100, and the other one under this same thing. So this is the same rectifier. RU888. Or this is an N-channel advanced MOSFET at 68 volts. The maximum current is 88 ampere, and the drain source RDS on, when it's turned on, is 6 milliohm. Gate source voltage is 10 volts. So that input capacitor is 62 volts. So the input here can never be exceeding 63 volts, otherwise these will explode, regardless of other design or limitation. So here is my setup. I'm using this 400 ampere shunt resistor to measure the input current and also connected the voltage. So it's being sent wirelessly to this Juntech monitor. This is just a power for this via USB. This is VAT4300. The wire that is coming, I've connected 6 AWG wires and also connected sensor. sensing for my electronic load. Now I'm going to test that input voltage is red here and current. This is output voltage, output current, and power if you want to read these three in here. Now I have set the output voltage to 19 volts. Input voltage is the same as before, it's 12 volts. The output voltage to 24 volts. Let's adjust it a little better. So output is 24 volts. Let's go 1 ampere. Input current is 1.9 or 2 ampere. 2 ampere from 12 volts to 24 volts. Input is 4 ampere. Here is the efficiency. 4 ampere. Input is 9.8 ampere. Here is the efficiency. 8 ampere. Input is 20.2 ampere. Here is the efficiency. Let's go 10 ampere. Input current is 25.25 ampere. Here is the efficiency. Let's go 15. The voltage has dropped, so not acceptable. So we are getting maximum of 10 ampere at 24 volts at the output. With 25 ampere at the input, that's the maximum. Let's go 2 amp. (72 watts). Input current is 7.5 ampere. Here is the efficiency. 4 ampere. Output is 145 watts. Input current is 14.7 amp. Here is the efficiency. Now 5 ampere. Output is 181 watts. And input current is 18.5 ampere. Don't worry about this negative because of the polarity. Here is the efficiency. 8 ampere. Now 8 ampere is the output. The power is 288 watts. Input current is 29.2 ampere. Here is the efficiency. 10 amp. Now the noise increased. Output is 352 watts. Input is 36.1 ampere. And here is the efficiency. Let's go 15 ampere. The voltage has dropped. It cannot handle 15 ampere as the output. Input current is 35 amp. Let's go for 10. At 12 volts input, the maximum that you can get is 10 ampere at 36 volts. Let's go 2 ampere. Input is 3.1 ampere. 38 watts. Here is the efficiency. 4 ampere. Input current is 6.5 ampere at 4 ampere, 76 watts. Here is the efficiency. 5 ampere. Input current is 8 ampere, 8.1, 95.5 watts. Here is the efficiency. 8 ampere at the output. Input current is 13.5 ampere. Here is the efficiency. 10 ampere. Input current is 17.3 ampere. Output is 19.2 volts, 190 watts. Here is the efficiency. Let's go 15 amp. The voltage has dropped, but we are getting 15 ampere or 295 watts. Input current is 29.1 ampere. Here is the efficiency. I'm sure it will not work with 20 amp, but let's turn it on. The voltage is now 11 volts, so it does not work. Now I set output to 48 volts. One ampere is the output. Input current is 4.1 ampere. 2 ampere. Input current is 9.2 ampere. 4 ampere, 192 watts. Input is 18.9 ampere. Here is the efficiency. Five ampere. Input current is 24.3 ampere. Here is the efficiency. 8 ampere. The voltage has dropped, not 48 volts, it's around 45 volts, so unacceptable. With this, we can get maximum of 5 ampere at 48 volts when the input is 12 volts. We start testing with 19.2 volts input. This is one of the standard battery voltages, so we will check with different outputs. I'm going 10 ampere. Input current is 12.9 ampere. Here is the efficiency. Let's go 15 ampere. So we did not get 24 volts. The voltage have dropped. So we can get maximum of 10 ampere at input, 19.2 volts at 24 volts output. Now output is 36 volts, 1 ampere with input 19.2, 2 ampere. Output, input current is 3.8 ampere at 36 volts. 4 ampere, input current is 8.9 ampere. Here is the efficiency. 8 ampere, and it's buzzing a lot. The voltage is still acceptable, 36 volts. Input current is 21 ampere, 21.6 ampere. If I go 10 amp, the voltage dropped. 8 ampere works barely. Now output is 48 volts with input 19.2. Let's go with 1 ampere. Input current is 2.5 ampere. Output is now 2 ampere. Input current is 4.6 ampere. Here is the efficiency. I just went 8 ampere and it doesn't work because it's not 48. Let's go 5 amp. Turn it off. So 5 ampere. So 5 ampere doesn't work. 4 ampere works. 4 ampere works, 5 ampere does not work if you want to get 48 volts from 19. Now we tested with 24 volts with different output voltages. 4 ampere input current is 6.2 ampere. Here is the efficiency. Output is 6 ampere, input current is 9.2 ampere. Here is the efficiency. Output is now 8 ampere, input current is 13.6 ampere. Here is the efficiency. Ten ampere does not work, the voltage drops. So maximum we can get 36 volts from 24 volt is 8 ampere. Now output is 48 volts. Output is 2 ampere, input is 4.1 ampere. Here is the efficiency. Output is 4 ampere, input is 8.7 ampere. Here is the efficiency. Six ampere does not work. Maximum you can get is 4 ampere from 24 to 48 volts. Now I set a new voltage, the maximum 24 volts input. Output is 4 ampere, input current is 5.5 ampere. Here is the efficiency. Output is 6 ampere, input current is 8.2 ampere. Here is the efficiency. Output is 8 ampere, input current is 11.0 ampere. Here is the efficiency. Let's go 10 ampere. Input current is 13.9 ampere. Here is the efficiency. I set output to 15 ampere. The voltage dropped. Input and output, as you can see, is just being reduced a little. So our input is just outputting. So let's turn it off. And turn it on. Now when I turned it on and off, input is now okay. Output is 36 volts. So 8 ampere works fine. No, again it goes to 26. 2 ampere doesn't work again. So 27 to 36 volts. 1 ampere is working. Let's go 2 ampere. 2 ampere is working. 4 ampere is working. 5.4 ampere. That's good. 6 ampere. Did not work. It goes to 26. Now let's set it to 48 volts in case if it can recover or work. Not sure. So output is now, I set output to 48 volts from 27 to 48, 1 ampere. Let's turn it on. So 1 ampere is working. Input current is 1.7 amp. 2 amp. Input is 3.1 ampere. Here is output 4 ampere. Doesn't work. Maybe it has been damaged because this is the maximum voltage. Let's reduce the voltage if it can. So yes, 24 volts it works. It seems the problem was with the voltage 27 volts. So at 24 volts it works. As you can see, 4 ampere, 6 ampere, it's buzzing a lot. 6 ampere, it's buzzing a lot. 8 ampere. 8 did not work because it goes to 44, but now the thermal image for input 18 volts, output 48 volts. You see it here. Let's go 8 ampere. The voltage has dropped. Let's go 6 ampere. And input is 24 volts. It's making a lot of noise. Let's have a look at the thermal image. 65 degrees. This is 130 degrees right now. $131. Ooh, very hot. Here, as you can see, the input current is 23 ampere. Output is 8 ampere. Here, output current is 8 ampere, and it makes this noise. And let's have a look at the thermal image. This is now 80 degrees, 84, 87 degrees. This inductor is very hot because 22 degrees is being drawn. Now input is 12 volts, output is around 36 volts. 4 ampere is being drawn here, and I'm going to check the thermal image and see where this device gets hot the most. So input is, as you can see, 15 ampere, and here I'm using this ZK thermal camera. I will provide you the link below the video if you want to have a look at it. Right now this area shows the hottest, 52 degrees. If I put my hand, you will see that this is the inductor. But let's turn this around and look at it from the side, or maybe from the bottom. And it's 44 degrees is in this area where my finger is, and here. Now I've connected the oscilloscope to measure the ripples. The output is now 48 volts. At 1 ampere, it is 696 millivolts. 2 ampere, $888 millivolts. 4 ampere, $888 millivolts. 6 ampere, 1.2 volt peak to peak. Now input is 12 volts and we'll see different voltages. Output is 19 volts with 1 ampere. 336 millivolts peak to peak. Input 12 volts. Output 24 volts, 1 ampere. (436 millivolts). Yeah, so we get almost 280 millivolts peak to peak. 6 ampere. (504 millivolts peak to peak). 8 ampere. So 8 ampere now. (2.96 volts peak to peak). Now 48 volt is the output, 12 volt is the input. 1 ampere. For the ripple, input is now 18 volts. Now input 18 volts, output 24. Let's go 4 ampere. And 1.12 volts the ripple. (8 ampere). (1.3 volts is the ripple. Now 18 volts input, output 36 volts. Let's go with 4 ampere and have a look at the ripple. 272 millivolts. Now input is 12 volts and output is 37 or 36 volts. Let's have a look at the switching frequency. (58.1 kilohertz). And it shows 58 kilohertz. So here is the conclusion. This module can handle some current but not 600 watts. I was not able to get any 600 watts even from 12 volts or the maximum 27 volts. So I went to 24 volts maximum. When you get 48 volts, and look here, 10 ampere, so that is 10. So 10 times 48, 480. So this is not now 48, this is supposed to be 48 volts. When I reduce the current, it increases. So under no circumstances we were able to get 600 watts, and also it was able to deliver different current rate at different output and input voltages, which I've just tested. Please watch them because that practical example is better than what I say. What is bad about this is that this cannot work with 27 volts. This cannot give you, and most importantly, this does not have current set. And this has not as constant current, so you cannot set the current, And the bad thing is here they put 80 ampere fuse, which means 40-40. So these two fuses are 80 ampere, and these are in parallel. These two fuses are in parallel, not for the output or input, and 80 ampere is a lot, so it will break the breaker or whatever you have somewhere else, or it will create huge hazard if you go with 80 ampere. But for the lower current, it's good, and that's it. Thank you for watching. Make sure to thumb up the video and also subscribe to my channel. When I post new videos, you will be notified.